All right, in this video, I'm going to show you how to evaluate a logarithm. Okay, what this statement says is log base 5 of the number 125. Okay, so 5 is my base and 125 is my input. All a logarithm is it's another way of writing an exponential statement. Like to figure out what the answer to this is, I'm going to write 5, which is my base. 5 to what power equals 125, right? And that's all a logarithm is it's another way of writing a statement like this. So they're just exponential equations without the equation, like it's without solving for x. But that's how you figure them out is you translate them to one of these, and then you just figure out what goes in the little box. Okay. So what do I have to raise 5 to get 125? Well, that's 3. All right. 5 to the third power is equal to 125. In general, excuse me, in general, the way that you translate logarithms would be log base a of y is equal to x. In the exponential form, it would be a to the x is equal to y. These two things are synonymous. They mean the exact same thing. All right. So remember, the base is always the number that you're raising to the exponent. And so that's what that is right there. They literally call it base A, though, when you're talking about logarithms. So you got your base. And then the answer that you get here is the exponent that you're trying to figure out in this statement. Okay. Let's do a few more here. All right. Log base 3 of 81. You don't always have to wrap in parentheses, but often I do. So what this means is 3 to what power, right? 3 to some power is equal to 81. Well, 3 to the fourth power is equal to 81, because 3 times 3 times 3 times 3 gives you this 81. So the answer to the statement is 4. All right. If I'm looking at log base 4 of 64, I'm going to translate that to an exponential. It would be 4 to what power equals 64? And that's just going to be the third power again. 4 to the third power gives you 64. So log base 4 of 64 is equal to 3. Some of them get a little bit harder to think about because your exponents don't always have to be nice whole numbers like they are here. Sometimes they can be different types of things. All right. In this one, I've got log base 4. So I already know I'm going to be answering the question 4, to what power log base 4 of 1/16. So I got to figure out what I need to raise 4 to get 1/16 as an answer. All right. Since my answer is a fraction here, I know my exponent's going to have to be negative. 4 to the second power will give me 16. 4 to the negative second power will give me 1 over 16. All right, this is just using my rules for exponents. A negative exponent flips it into the denominator. So log base 4 of 1/16 is negative 2. If I'm looking at log base 36, so again, it's 36 to some power, is log base 36 of 6, means I'm asking the question 36 to what power will equal 6? Well, I know the square root of 36 will give me 6, and square roots are just the same as fractional exponents. So this is 36 to the 1/2 power. So log base 36 of 6 is equal to 1/2. Some of them are very predictable. If I look here, this is one of the special cases. log base 20 of 1. All right, this is asking 20 to what power equals 1. All right, what do I have to raise 20 to get 1 as my answer? That would be 0, because everything to the 0 power gives you 1. In fact, anytime that you're taking the log of the number 1, all right, so regardless of the base, log base anything of 1 is always equal to 0. All right, this is one of those special things that you want to memorize. And this is because a to the power of 0 is always equal to 1, no matter what the base is. Another one that's kind of special is log base 7 of the number 7. All right, this is asking, what do I have to raise 7 to? What power do I have to put here in order to get 7 back as my answer? All right, and this would be the first power. Okay, so log base 7 of 7 is 1. And again, that works for all bases because if you take anything, all right, and raise it to the first power, you get that same anything. All right, so if I say, a to the first power, I get a, and that translates to this right here as a logarithm statement. So log base anything of the same anything is always equal to 1. All right, so these two right here, these are definitely worth having. So these are all pretty straightforward. I hope you're just figuring out what the exponent has to be in order to complete the equation. Some of them are a little trickier. Here I'll look at log base 8 of 32. So if I translate this to an exponential, it would go, 8 to some power. What do I have to raise, the number 8 to get 32 as an answer? All right, this one isn't going to be so cut and dry. I know it's got to be bigger than 1, but less than 2, because 8 to the first power is 8, 8 to the second power is 64. So it's somewhere in between there. This is one of those where we can rewrite both sides of the equation as some power of 2. I can rewrite the number 8 as 2 to the third, and I can rewrite the number 32 as 2 to the fifth. And then you got a power to a power, so this is going to be 2 to the 3x is equal to 2 to the fifth. And then you can equate these two exponents now that the bases are the same. So you just have 3x equals 5, or x is equal to 5/3. Right? So if you do 8 to the 5/3 power, you're going to get 32 as your answer. So that means that log base 8 of 32 is 5/3. Right? It takes a little bit of practice, but that really is the general idea for a logarithm. It's just another way of writing an exponential equation like that.